All right, good afternoon. Uh, Today is February the 10th, 2025. We're going to talk a little bit more about the programming stuff. We're going to focus on question number 4 from last week. We got some math stuff over here. So we're going to incorporate some if statements and all that other good stuff. If you notice, I put in the announcement, and I've tried to be prepared here. I put in the announcement, and I'll kind of control plus here. We're going to talk a little bit more about if-then statements, and then what we call compound if statements or conditional if statements that we've done in GIS. We call them ands, we call them ors. The and is what we call an intersection. When we talk about the intersection of two streets, what is the intersection of two streets? Literally where they meet, the area that's common between Concord Street and Lawson Street, that actual like physical rectangle, whatever it is, it was at the intersection of those. And that's going to be a lot more restrictive than the word or, meaning it was on Concord Street or Lawson Street. So it could be at the intersection, it could be on either one of those streets as well. And so it's a lot more, the and is a lot more restrictive. And so I put some examples here with the hypotenuse question where you went through and calculated it, where you have to type in a positive number. And so if you said, and I have a document or I have a statement here that says text window dot write, please write your first leg and your second leg. These are going to read numbers. And so remember, if you try typing in like an A or B or whatever, it's going to let you type it in. It's just looking particularly for a number, but we also want a positive number. And I don't think there's a read positive number. It's just a read number. So we need to say if leg 1 is less than or equal to 0, or leg 2 is less than or equal to 0, because you can put in whatever you wanted to. We're just going to write, hey, we cannot compute this because one or both of the legs are not greater than 0. Okay, because we're working with triangles, so the numbers have to be greater than 0. Else, we're just going to calculate the hypotenuse in this section. So you're going to utilize the mathematics tools in the print so we can do this. Now, what I want to do today for the first part of class is go through and look at question number 4. So anyone who turns it in from now on, this point forward will not get full credit just because we're going through the answers right here. And so I've got the formulas up here. And so I want to go through and calculate this because the best way to make sure your program runs is to do what? Calculate it by hand and make sure the numbers work. Because I've kind of gone through it and done this a little bit. So we have a quadratic formula. You probably learned this in high school at some point in time. Negative b plus or minus the square root of b squared minus 4ac all over 2a, where that a, b, and c are the coefficients of your first order, second order, and then your whatever this thing is. What's this number? Variable or whatever this thing is. Your c right there. And so it calculates both of the roots right here. It calculates both of the roots. Now, in math class, we did all this factoring stuff. So something like x squared plus 2x minus 15, we turned it into factors. What's a factor? What's it? Close to derivative. It's just two numbers that multiply each other to make a product. And so if we know that a times b equals 0, it needs to be true. A is equal to 0, or b is equal to 0, or both of them. So you create these little factors, and you said x plus 5 equals 0, or x minus 3 equals 0, and x is equal to negative 5, or x is equal to positive 3. And that's what it is. X is equal to negative 5. And then if you plug the 5 back in, what do we have? 25 plus negative 10, which is what? Minus 10, which is 15 minus 15 equals 0. And a lot of times it doesn't show up like this. You might get something like x squared plus x minus 15 equals x. You move everything to one side and all that other good stuff. Now, the other way that we can do this is that we can plug this into the quadratic formula here and solve for it. So we can go through and solve this. We'll do it real quick. We won't do it for the second one, but we have R1 negative b, which is equal to what? Okay. Negative 2 plus the square root of, hopefully, This thing better be nice, something nice and neat. But b squared, so 2 squared minus 4 times 1 times negative 15 all over 2. Negative 2 plus, this is 4 minus a negative 60. Do you see what's going to happen right here? Negative 2 plus the square root of 64 all over 2. Now we get what? 2 plus 8, which is negative 2 plus 8, which is what? 6 over 2 equals 3. Yeah, or negative 2 minus 8, which is negative 10, divided by 2, which is 5. So we can use this one. We can use this as a template. So when we go and write our little program, we can calculate this thing here. But we know if we start calculating square roots, which are negative, what's going to happen? Things are going to go real south real quickly, like we did with that division by 0. Okay? So the trick is, what do we need to do? Well, I'm going to just start this program right here. But now look what I have here. I already have a text window dot write, and so we're working on question number. So first thing I'm going to do is, what are we going to ask for? You're writing a program to do the quadratic formula. What's the first thing you want to do? Ask for the first thing. Please enter A. We put a prompt here. Please enter A. And what do you think the name of that variable should be called? A. That's a good idea. Now let's write it all again. Nope, let's just cut and paste this stuff. We're just going over last week's stuff here. I give my little spiel and then we'll kind of start. So what should we do here? B. B. Okay. So now what do we have going on here? All right. So now we've asked for A, B, and C. Okay. A, B, and C. And we can type in whatever we wanted to right there. What's that big fancy word for all this stuff under the? What's that? It's called discriminant, right? Discriminant. What's the variable that we want to use for it called? We'll just call it discriminant. Equals what? B times B minus 4 times A times C. How do we write that? How would our Aunt Sally like us to write that? Yeah, we have some parentheses. So B times B minus 4 times A times C. And just for the heck of it, what do we want to do? Hey, let's just print it out. Okay, text window dot right line. Let's just run this thing. A, what do we have here? 1, 2, negative 15. See, all that stuff is equal to 64, right? This number right here, 64. Cool. I'm big into these print statements, big into the print statements. All right, so next. What happens if it's negative? We want to check to see if the discriminant is negative. What happens if the discriminant is negative? We don't run this thing. So if discriminant is what? And I think I can do this, right? Discriminant. What if it's equal to 0? Is that okay?
Yeah, there can be like one solution, right?
Yeah.
It's equal to the-
Double, what we call double root, exactly. So x squared plus 6x plus 9x plus 3 times x plus 3, x is equal to -3. So discriminant is equal to 0, is less than 0, then what do? Yep, text dot break line. Okay. What does it mean if the discriminant is less than 0? What does it mean about its roots? What's it mean about its roots?
Doesn't have any, or they're negative.
They're negative. Square root of negative number is what? Not real. Exactly. That's exactly. Okay. Roots are not real. Goodbye. And we're going to put an end if here. All right, so what are we going to do next? We went through the trouble of figuring out the discriminant, so what are we going to do? Root 1 is equal to what? -1 times b plus, how do we do square root? Did I provide a link for this? SQU. I got something here called square root. Let's just cut and paste this thing right in here. Square root of what? What do I want to take the square root of? It's discriminant. What is that variable called? DISC. Discriminant. And let's divide it by 2 times 8. Okay, does this look okay? All right, and just for the heck of it, let's just do it again. Let's just do it again here. Text window. All right, we'll just say root number 1 is plus. Okay. All right, let's run this thing again. We know these numbers are going to work. So how about we type in a 1, 2, -15. Root number 1 is 2. But we got -5 and 3. So am I wrong over here, or is the program wrong? What's wrong with the program? What would your Aunt Sally say about it? No? Parentheses, exactly. Okay, what is it doing right now? This code here takes the square root, divides by 2a, and then adds the whole thing to -1 times b. Is that really what the intention of this is here? No, put it all in parentheses, because basically in your order of operations, please excuse my dear Aunt Sally, parentheses, multiplication, division, or exponents, multiplication, division, basically multiplication and division are the same thing. You know, so division, you know, it's just the same thing. So what do we need to do? We put a parentheses here. Parentheses here. Now let's try it. Okay. 1, 2, -15. Root number 1 is 3, right? Okay, we went through and calculated it. What do you think root number 2 is going to be? Can I just cut and paste this thing? What should I call root 2? 2? What's the only thing I have to change in this line right here? Positive to a negative, or a plus to a minus, the operation. There it goes. All right, so let's try it again. 1, 2, negative 15. Uh-oh. What did I do here? I still printed out root 1, root 2. Root 1 is 3. Let's do the example that David had. 1, 6, 9, negative 3, negative 3. Double root. What are some other kind of funny cases that you could think of? 1, 0, negative 25. X minus 5 times x plus 5, those 5s kind of quote unquote cancel out. What happens if a is equal to 0? Well, let's try it. All right, ready? A is equal to 0, b is equal to 5 and 3. Doesn't like me. Why not? Let's get rid of this discriminant thing. What's the problem with that? If a is equal to 0, what happens? What happens when we divide by 0? Really bad things happen. Yeah. Okay. All right, let's run this for some other things here. Like 1, 6, 12. Roots are not real. Why? No negative numbers exactly, and it's not going to be a double root. So b squared minus 4ac, so 25 minus 4 times 1 times 12, which is a big number. We're going to get something like negative 23. What does this make it? Negative. Roots aren't real. Let's put in some other neat things here. Because most of the time your teachers set it up so they just round out nice and neat, but in reality, that's not how life exists. You know, we put in like a 2, a negative 5, a 48. Okay, let me put in something that really works. Okay, I swear I'm going to find something that works. 1. Okay. I'm really struggling. We gotta get a small c. There we go. Okay. What kind of numbers are we looking at here? What are these numbers you think they are? Irrational numbers, right? You know, so now when we have the b squared 100 minus 4 times a times c, this is like the square root of 86 or something like that. What's the square root of 86 equal to? Something that we don't want to do. Something we don't want to deal with. Let's try one more where we do run A is equal to 0, 5, 16. Oh, I guess it just rounds it out to 0, makes them both 0. Okay. Okay. I don't really like that too much, but all right. Any questions about this one here? We feel good about, the whole methodology here. Do you want to try running the square root of a negative? No, we don't need to see what happens to the computer when we run the square root of a negative. Okay. We'll just, we'll spare everyone here. All right, so we're going to talk, today we're going to talk about loops. You can see the announcement that I posted here. Take advantage of the resources because next week we're going to start doing some Python within the confines of ArcGIS Pro. So I've got some of the math operations that I have here. I have introducing small basic. We have a couple of programs to write, and those will be due here. So I did write a couple of programs here. And so if we download, open up everything here. I got things like, I'm going to go through and like draw circles. Some of these things like this is pretty cool. What else do I have here? Event handler, prime numbers, Pythagorean triples. Oh, wow. Okay, I like this one. All right, so today we're going to work on some loops. And so we'll kind of talk a little bit about the homework and, go from there. But so today we are going to talk about conditions and loops. We kind of looked at those a little bit because we're going to go through and do things multiple times over. Remember week number 1 homework where you had to like literally go through and run it once, run it again, run it again. And Andy was doing some pretty slick things in the background to automate those processes. And we can do those with Python as well. We can go through and do calculations that are going to be really robust. So we're going to write programs that carry out different instructions for one or more commands that are true or false or whatever. And so one of them was discriminant. If the discriminant is less than 0, then what? Don't run the program. You're going to crash the computer. You're not going to crash it. It's just going to say not a number and doesn't work. And we're going to calculate it. Same thing with the hypotenuse. Who did the hypotenuse problem? Who did the quadratic? Did both of them? Overachievers over there. Okay, that's okay. But you do the hypotenuse one, it kind of works the same way, and I specify you put in a negative, you put in a negative, but you got to assume someone's just tapping stuff right here and they're going to put in nonsensical stuff because the programmer is going to go through and do the same thing. So you got to kind of cover your rear end on all these. So we're also going to write programs that repeat instructions until a specified as well. Make sure if you're online here, just mute yourself because I hear a little background information going on here. Background sound. So we have conditions. What are some of the conditions? If the discriminant is less than 0, then do something. And the syntax for this is going to be really simple. If, then. The only thing you need to learn with different languages is this: how does that syntax go? In the C programming, I think it's C that you put everything in the little parentheses right there. Sometimes it's two equal to signs next to each other. And so we've got a little program that says if clock.day equals 1 and clock.month equals 1. So I guess we have something here called clock, right? Now, how do I know? How can I check if it has clock? And a lot of times we use these words objects, but I can just open up my ArcGIS. I can open up my small basic. Come on, small basic. Come on. You know, I'm running a lot of stuff here. Okay, just for the heck of it, I can open up a new window here and I can just do a clock, dot, and look at all of the different commands I can have under clock. I have something called date, year, weekday, time, second, month, elapsed milliseconds. This gets the number of milliseconds that have happened elapsed since 1900. What's a millisecond?
Thousandth of a second.
What's that? Thousandth of a second. So I would just love to see, right? Text window. Dot right. How many milliseconds do you think have happened since the year 1900? That many. That's a big number. Let's do it now again. A few milliseconds later, that many. That's a big number. But we can type in these clock dot D. And we can look at the format 2, 10, 20, 25. So we have a lot of different commands that we can access it. Hour, millisecond, minute, month. What do you think 2 means? February, exactly. So we can check different months or whatever. So I always like playing with these because what's the worst that's going to happen? You know, this isn't brain surgery or anything like that. Hour, minute, month, second. 29. 33. So that's the second then. Was that?
What clock is that based on?
Probably just my computer. Yeah. Right. These things aren't very, it's just looking off my computer. You know, there's probably some sort of system here. And so what do we do here? If clock.day equals 1 and clock.month equals 1, then text window.writeLine equals Happy New Year. All it does, if it looks for the date and the month are both equal to 1, what if I use the word or? What is it going to do? What is it going to print out Happy New Year? The day of the month. So it'll print out Happy New Year every day in January and then every first of the month. So we're looking at like 33 or 43 different days where we have those. But really simple commands. So we have if something, then something, and then we have this end if. And to me, I always have to go and check to make sure this is what we call syntax, because for the if statements for Python, there actually is no end if, because we just move, we hit the little tab button and it says anything that's this direction here is just working off of this if, we go all the way back. So other things that we have, some other conditions, write a program that specifies an alternative action to specify if it's false. So like we just did, if the discriminant is less than 0, we're going to do something. Otherwise, we are going to do something else. So if clock.hour is less than 12, then text window.writeLine, what did you have your breakfast? Otherwise, if it's greater than 0, did you have your lunch? That's pretty simple. Okay. So really straightforward here with these if statements here. So depending upon when you run the program, it'll display one of 2 results. Here's one, here's the other. All right, let's get a little bit more complex here. Okay, we have another condition here. Is that did you have breakfast? Did you have your lunch? And repeats a lot of the same information. Also, we have something called else, meaning do one or the other. So what I could have done before is, did I use the else or did I say if it's greater than 0? Let's check what see what I did.
Yeah, you can go.
I used else. Okay, good. I thought I was. Thank you. Even if I didn't, thank you. Okay, yep, there we did, else. And so there's only one of two possibilities. The discriminant is less than 0. Otherwise, I don't care if it's 0, 27, a million. I don't particularly care what it is. It's just the other one or the other right there. Okay, one or the other. So we use the else statement. So both programs have the same result, but what we want to start to do is optimize our code. And when we start getting to things like calculating Pythagorean triples, and calculating roots and all those other things, it gets, we can run, 20 loops, our computer's not going to notice. But when we start running like multiple loops with millions and millions of calculations, that's where it gets really ugly really quickly. And we're going to look at some of those optimizations here. Another thing, is a number odd or even? Now you're going to write a program that figures out if something is a prime number. What's a prime number? Besides what?
Or besides one in itself.
One in itself. One in itself. So something like 7. Is that a prime number? Yes. 23, 37, 43, 47. Can you think of any other numbers that go into 47 besides 1 and 47? No. So that's a prime number. Now, what do we have here? Math.remainder. And this is what we call a function that takes in 2 parameters. So it takes in 2 parameters. What do you think the first one is? The number that we're talking about. What do you think the second one is? 2. What are we looking for here? If remainder equals 0, then the number is even. Otherwise, the number is odd. What's a remainder? When I do a division, I do a remainder. What does that mean? You do a little what's left over. I don't know how many people took math where you had to do this little thing here. You had like 17, 2, and you do 8, and you do 16, and 1, and the 1 doesn't go on the 2. So you're like 8, remainder 1. That's what I had to do. Anyone remember this or no? Yeah. All right, David does. Erica does. Will does. That we used to have to do that stuff, just like that. Exactly like that. But that's what the remainder is. Now, does anyone know what it's called in other languages? It's not called remainder. It's something called a modulus or modulo. Has anyone heard that term before? Modulo. And so I don't know what Python has, and we'll figure that out later with Python when I go and revisit it. Okay, so we enter a number 256, 265. Is there a remainder? What are the possible remainders that you can have for 2? It could be either 0, 1. 2 possibilities. If it's odd or even. Now start to think about, all right, I have 27. How do I figure out if it's got factors? Well, that's going to be a little trickier. Okay. All right. So you got to figure out, all right, well, where do we start at? 1 is always going to be not have a remainder. 2, 3, 4, 5, 6, 8, 9, 10. So you guys have to figure out how far are you going to count up. This is where we kind of get into some programming and logic and all those other things. And so we've got these conditions right here, and we can kind of think about that for some of our prime numbers. I like to kind of write through a little bit of code or pseudocode or whatever we have to kind of figure some of these out. And so basically you're writing a complex program and you want to check to whether a number is odd or even. Because we're going to figure out the roots of a number, or how many roots does it have. Be pretty cool. Or you can write a program, all numbers from 1 to 200, and you count the number of roots there are and look for all the prime numbers. You're all kind of looking at things, looking at functions of this that do the same general thing. So we have if, then, else. We have an if, we have a then, we have an else. There's only one of two possibilities. either has a remainder of 0 or it doesn't matter. Does it matter if it's 2, 3, 4, 5? It's not going to be in this case, but later we're going to look to make sure it has a remainder, because basically the number 31, if you were to divide 31 divided by 2, divided by 3, divided by 4, divided by 5, divided by 6, divided by 7, is there ever going to be a remainder of 0? No. Now, what do we go up to? Do I need to go all the way up to 31? Oh, why not? Because 31 over 27 will never have a remainder because it's more than what? Half. So you could just stop at half of 31. You could actually stop at the square root of 31, right? Because if I'm going up to 40, if I do 8 divided by 5, what's the square root of 40? 6 point something? If it's 5, then I know it's going to be 8 is the other one. 5 and 8. Okay, on the other side of that square root. And so we can kind of think about those a little bit later there. Okay. If I were to type in like a million, and I don't want to make your computer crash. So other things we have. So we have different conditions. So what's the current temperature in degrees Celsius? If the temperature is less than 5, it's very cold. If the temperature is less than 15, then it's cold. Else, if the temperature is less than 25, else it's quite hot today. I assume they're doing Celsius here. Okay, I don't like those temperatures. It's hot. Okay. And so one of these statements need to be true if we do the else if, else if, else if, else with the end if. Okay, something's going to happen when it enters this loop. Okay, something will definitely happen. Okay, and so we can look at some different examples. And so we have different conditions. The other things we're going to go through and do loops. Now, I was just telling you, like, hey, type in a number. Let's see if it's prime or not. That's going to be kind of tricky. You know, I kind of like that idea. What are we going to go up to? We can think about some of these and fine-tune these applications a little better. So we have loops. So I type in a number 47. I type in a number 48. We're going to see if it's prime or not. Oh, maybe we can count up all the factors. So we can use a loop to instruct the computer to run one or more statements more than once. Kind of like we did with week 1, like you're doing the same thing over and over when you copy and paste that stuff into Excel. And I bet you there's a really easy way to do it. Now, if you're only doing it 7 times, it's probably not going to matter. But if you went and downloaded a year's worth of data, you're not going to do that. Hopefully you'll write a loop and then stick it at the end of your code and call it a master's thesis or a dissertation. That's what you're going to do. Okay, that's what you would do. Okay, so we can do something called the for loop to go through as many times as we want. Now this for loop, and we're going to look at examples of this for loop here. So you can use the for loop if you want the program to repeat instructions until a condition is true. So let's see, we got a couple of loop statements or for loop statements. So we've got a for loop right here. Let's see. For A is equal to 1 to 10. How many times is it going to go through? 10 times, and it's going to print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can hit the little button, and what are we going to have? We're going to just print out these numbers here, and we can cater that output using our concatenate sign. What's this big fancy word concatenate mean? Join, add strings together. To me, it's just adding strings. Like 6 plus 9 equals 69. Why? Because that's the string. Now, if we did it literally with math, it would be equal to 15. So we can pick any key to continue right there. We can do this. Now, when we're doing the prime number and I type in 27, how far do I want to go up to? 27 for now. Okay? For whatever the number is. Does it have to be 10? It could be X, whatever I type in. So I think we'll kind of look at that after our quick break right here. So it increases by 10 every time. So we've got some basic loops here that we have. So we've got a nice little multiplication table. What do you think like the first exercise that we have is do a little multiplication table that we have. And the output is going to be like 1 times 5 equals whatever. So what I'm going to have you do is you're going to the user is going to type in a number and then you write out the multiplication table. So you can see we've concatenated this string where this is the variable plus this X, meaning that the times sign, plus another number right here that we typed in, and that number can change based on a read line or read number equals this. So you could do your 5s, your 6s, your 10s, your 23s, your 87s, whatever you want, all the way up to 10. But you can see the concatenation of this string because at the end of the day, we just want to look at stuff like this. That's all I want to do. Of course.
So see, so okay, right before number, you've got the symbol on the computer that we use that. So that actually means multiplication.
Yes.
But where we have X in quotes, it's just reading the X.
Yes. It's just writing out the X so we can do it. Exactly. So this star means you're actually multiplying A. Well, the first time it goes through the loop, what's it going to be? 1 times 5. Next time it goes through the loop, it's going to be 2 times 5. Next time it's going to be 3 times 5, 4 times 5, 5 times 5. Okay. Now we're going to change some of these loops here to make them a little bit more dynamic. Okay. So we can multiply odd numbers times 5. So we have something here called a step. So for X equals 1 to 10, step 2, meaning, what's the step mean? You go up 2. So we start from 1 to 3, 5, 7, 9. So 5, 15, 25, 35, 45. So instead of going up by 1, now when I do without any steps, the implication is that it's a number. I can do step 0.1. What do you think that's going to do? 1.1, 1.2, 1.3, 1.4, 1.5. I can do negative steps, but that gets a little ugly. If I want to go from 1 to 10, step -1, it's not going to understand that. I go 1, -1, well, you'll never get there. And so you get me stuck in what we call an infinite loop. It'll never be satisfied, which you don't want to happen. And so we can increase by 2. When we create a while loop, I like these while loops because this is a condition that's true. Because next time, what we're going to do, we're also going to write a little game where you have to pick a number between, the user has to pick a number between 0 and 100, and then you write a program to figure out how many guesses it takes them to do it and to see if it's right or wrong. So what is that while statement? You know, hey, while like your guess is wrong, while we've got to figure out some sort of condition here. One of the things that I have is what we call a flag, and I'll talk about those a little bit later, meaning, hey, flag means that the condition's been satisfied. Okay, hey, you won the game or we did whatever. And so if you don't know the loop count before you go in, because when we go from 1 to 10, how many times is it going to go through? 10. Okay, or I type in, type in how many years you want to compound the interest, 16. It's going to go through 16. So you put in a for loop, but a while loop is going to satisfy conditions until it actually gets there. So A equals 10, while A is less than or equal to 100, then we just write line and then A equals A plus 100. What does the word equal to sign mean? What does it mean in computer programming? Assign, take on the value of. So when I get to this line here, I'm going to write out 10. Then I'm going to say A is going to take on whatever the value of A was plus 10. Next time I go through, it's going to be what? 20, 30, 40, 50, 60, 70, 80, 90, 100. What happens when I get to 110? I'm out of there because this is the condition that it needs to satisfy. And we're going to look at all different types of examples here. So you can see go up to 100, and then once it satisfies or stops satisfying that condition, it's going to get out of that condition here. But we have a loop down at the bottom, which is called end while. So our end while loop. Okay. So we've got a couple things here. We're going to go through and write some good examples. We know how to write programs that evaluate, write programs that repeat one or more instructions, and based on logical conditions. Okay, what I want us to do here is, we can convert scales and all this other stuff. I think we're going to let's take a quick break here. We'll come back at 6, and then we are going to start working on I'm gonna have a couple problems here. They'll kind of blend into the homework, and then we'll kind of think about what we can do from there. Okay, so let's take about a 10-minute break. And let's get our small basic up here ready to go, and I'll kind of give some marching orders here of what we're gonna do, because I just wanna write some code here, okay? And I wanna write some code, and then we'll kind of think about how to logically do this. So let's take about 10 minutes here. And I don't wanna stay till 8 again, so. I gotta be in Raleigh tomorrow morning, so I have to go home. The what? Oh, she's stepdaughter. You see my Instagram or my?
No, you don't like that. Yeah.
Yeah, we got stuff.
Before I leave, people be. Yeah, I don't want to be sit there just like.
Yeah, okay, so we got someone new. What's your name? Is that Genesis? So you taking the online section or take the case?
Right.
That's fun. Did you install software and all that? So what's your major? You one of our majors? Cybersecurity, okay. Master student, undergrad?
Yeah.
You take it 5,000. 4,000, it's 5,000. So also grad school. Oh, you getting out of it?
So I eat a whole bunch of like food and sugar.
Caffeine.
Yeah.
Yeah.
So what's gonna happen?
That guy with the bull shirt, he's our TA.
I feel less like
So-
because the sugar.
It's Andy, and then the other guy that's side shirt is Chima and myself.
So it's not
We
steak.
small software.
It's breaks
Uh,
up.
You had a computer here?
So it's a sugar. So you put it.
Well, the stuff we're doing here, this program.
If you really fun, you say, well, all right.
Yeah, sure. Okay, okay.
I like water.
All right, Andy, can you see if we can get the small base installed? Now, you shouldn't get, I used to, we started and then the architect, we started next meeting. They kind of hoping people came in, I taught a geostats class last night, that's what everyone here taught at work, so. Hoping everyone came in with. Yeah, some of that, okay, good. All right, cool, so we can have that in the GIS stuff. All right, good, all right, eat the happy.
But okay, that was like this morning. What did you bring? Yeah. Let's see it go. I really, they smart, you work smart, not hard. Expensive. It's not, it's the point, they take it first. They take
Yeah, the stuff like that. As soon as you get up.
Yeah, that's where all my was for today. This morning. I promise you, the rest of the day I'll remember. You won't. See that?
What? We're gonna be doing a open science class. Yep, that's like week, yeah.
So, try. Yeah.
Okay, so that's, hey, things like. And you must say.
Yeah.
I think it's.
Yeah.
Okay,
Yeah. You know exactly what you're talking about.
yeah, I was just wondering.
Yeah.
With your team because I'm choosing. Sometimes team just like. So it's like. No temperature here. See, see. That's what I'm saying. So if you go outside, there's like sun, stuff. But the temperature here in sky, you know, right, it's just. So tired. So. Yeah, that's fine. As long as you know. You don't even have to monitor pictures. Yeah, after this week. Try to get something after the season. We're just. Get rid of all the top seats. Get some water at least. It's good to have a lot of water. The same time, still like, so trust me, just not build, you know.
Exactly.
So,
Yeah.
just me, it's. You have just, what else? Like, once you have a teamwork, and then take off the, if I say that's what attention.
Yeah.
That's wrong. That's the thing. Also say you guys think this best. I feel like I'm too much. I feel like I'm almost like halfway there. We're trying to play this. You start to look like a year. So, but I'm thinking, you started school at now. You're starting. Sweet, yeah. Just ages. Just not time. So. It's always my diabetes over. That's a requirement. And then I'm doing this. That's. Maybe.
Similar, but.
No. That's.
Yeah, I don't think that's, I don't know, but. Very, thanks. Synopsis.
Yeah. We got 6 persons.
City West. Welcome sold. It's like 7.
Oh.
Smaller garage. This stuff is preparing for your.
Exactly.
Yes.
Just want to grind
Might
it
as well.
right.
You guys.
We would, myself. Since ourselves.
They still.
No, Robert wants to see if you can see. Then I'm looking at some of my spraying. First. All that.
They weren't there.
Because we're trying to see. Distance all the time.
Yeah.
The class is so deep.
Oh, yeah, that's, she told me she would send us.
That was me.
I just get Mary was talking to her last night.
No, it's self-based. The last thing is good more those.
That's crazy.
On the so streets and emails. On email.
Yeah.
But legally responded.
Yeah. Yeah. Right, so we have, I'm getting done.
But it's a bit overwhelming because.
There's- Like when you got involved.
You know, I was just my house and so on that.
Because you know, yeah. Someone about in class now. Okay.
But you say it stayed in that class.
Yeah. That's what I'm excited about.
Okay.
Usually viewed it as. Yes.
Yeah, Thank you.
I don't know how many. Yes.
See, why should that?
Not really, no. It's not looking on our computer, so. All right.
Yeah, but that is nice.
All right, 6 o'clock here. I gotta go to Raleigh first thing tomorrow, so I kind of want to get out of here. All right, so a couple things up here. Hopefully everyone can see this as well, joining us online. I want to write a program. We're going to write about 3 different programs today. I want to look at the idea of nested loops, conditional statements, and these are all going to integrate loops. But the first thing I want to do, I want to write a program that does 3 things. One, it asks for a positive number. Okay? We know what that means. We know how to do that, right? Read number. Second thing, we want to see if it's prime. If it's not prime, what's the other type of number? Starts with a C. Composite. Okay? Composite. And the last thing we're doing, while we're there, we're seeing, hey, let's count the number of roots. Because there's a lot of different ways we can do this, meaning we can do the remainders, and then if a number has 2 roots, what does that mean? It's prime. If it has more than 2 roots, guess what? It's not prime, it's composite. So there's lots of different ways we can do this. Because just think about this. I'm going to type in a number here, and the number I type in is 48. How can I count the number of roots and see if it's prime or composite? What do I start with? Let's start with 1. and just say, hey, does 48 divided by 1 have a remainder? Does it? That word is remainder. Does it have a remainder? No. So what's that mean? Ding, 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 that's the root. Let's go to the next one. Does 48 divided by 2 have a remainder? Ding, ding, ding. It's the root. Does 48 divided by 3 have a remainder? Yeah. Ding, ding, ding. That's a root. So we're going to have a variable called root. Well, hey, if it has a remainder, it doesn't have a remainder, guess what? We're going to add to a variable called root. And then when we get to the end, if it only has 2 roots, then it's a prime. And then we're going to think of ways to kind of better streamline this. And let's go all the way to 48. Does 48 divided by 48 have a remainder? No. So it's a root. Okay? So we can go all the way down. So what kind of loop am I going to? For loop. For x equals 1, 2, whatever number the user types in. I typed in 48, you might be 47, you might be 123 million. Okay, whatever you want. Now let's type in really, really big numbers to see how long it takes those to run. And then maybe we can streamline this because I took a class a long time ago called algorithm design. Meaning we have to go through 48 times. Okay, I don't mind going through 48 times, but I don't want to have to go through 100 million times when I can only go through, 50,000 times or 50,000 calculations. Because we're going to look at something called while statements next, and then we're going to look at nested loops, and hopefully we'll have a good enough of an idea to go ahead. So we're going to start writing our code here. Okay, what's the first thing we do? Let's ask the user for a number. All right, what do we do here? Okay, we got that installed there. Good, Dennis. Or thank you, Andy. You got that installed? Did you use the double secret probation password for that? Okay, cool. Does anyone know? Someone knows what double secret probation means. You do, right? Animal House, very good. Do you remember that, Will, or no? Double secret probation. Yes. Oh, good. Anyone ever hear the movie Animal House? No. Came out in like 1980.
Yes.
Oh, good. Gray did too. All right, cool. Check it out sometime. Really funny. Over. No one says it was over. Was it over when the Germans bombed Pearl Harbor? Oh, you guys remember this. Okay. Homework. Watch Animal House this week. Okay. What's that? It's a movie.
We didn't have series.
They didn't have series. Like, you missed this show in a series like Different Strokes.
Oh, man.
You're like, you had to get asked for friends. And then they had like 2-parters, and you're like, uh-oh, Brady Bunch. Like Brady Bunch, Different Strokes. What's gonna? If I miss Different Strokes, like it was like life or death. Yeah. So that was my childhood. Now I just Hulu it. My kids are spoiled. Yeah. Yep. Okay. All right. All kidding aside, first thing we need to do is, hey, let's do a window dot right line. What is it called? Text window dot right line.
Yes.
Text window. Okay. Text window dot right line. What's a nice way to ask for a number? Please type in the number. Yeah. Please type in a number. A little colon here. Okay. And just for the heck of it, I'm going to type in a positive number. We're going to go back later and vet out the negative numbers. For now, let's just write the base code because we might have to stick something into an if statement, but we'll deal with that later. Okay, what do we need to do next? Okay, text window dot read number. And then what do we want to call the number? Number? Okay, cool. Equals what? So what are you gonna type in? What's the user gonna type in? I don't know, could be 48, could be 1,000,000, could be 17, could be 23. Let's forget about the negatives for a little bit. Okay? So let's do that. Now, next, what do we want to do? We want to see if it's prime or composite. So we're going to have it go through a loop that goes from 1 to what? What's it?
What's a number?
What's number? What's this number called? Number. Exactly. It's number. That's it. Just for the heck of it, 4, we'll have a variable called x equals 1, 2, number. And 4. And just for the heck of it, guess what I'm going to do? I'm going to just do text window dot right line and I'm just going to type in the number x because the first time it goes through, what's x going to be? 1. The next time it's going to go through, it's going to be what? 2. The next time it's going to go through, it's going to be 3. Next time it's going to be 4. What's number going to be every time it goes through? Whatever the user types it in. It's going to always be 48. So this number, this x, is going to be what? The denominator in the number when we check to see if the remainder. And just for the heck of it, I'm going to do text window dot right line x. And I just want to see if I get here. So type in a positive number, 17. And what do? I just go through and print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. Right? And I just like using that print statement as kind of my debugger. You know, what happens if I were to type in, 10,000? Uh-oh. There it goes. Look how quickly it did a 10,000. Let's go print out 10 million. All right. I did something really bad. So, yeah. Darn. Okay. So on this computer, this computer's fast, but it's, everything else. So, okay. All right. So I'm going through this loop. So what do we want to do? What do we have to check? What does it mean if it's prime? What's a root? What's all this stuff here? Let's go do this first calculation. Okay, now how do we put this in computer code? That's the trick. How do we figure out if something's got a remainder? Didn't we just look at this before? All right, let's go over here. All right, let me do Control F, remainder. Here it is. Now what's the dividend? What's the divisor? Number 48. What's the divisor? X. First time it goes through is going to be what? 1, then 2, then 3, 4, then 5, then 6. Equals 0. Then what? What do I want to do? Oops. What do I want to do? Me, I'm just going to print something out. Hey, I'm going to get to my little print statement. I'm going to say, hey, x plus is a root of How's that? What am I writing out here? Now I'll run this first. Oops. Right line, right line. Yeah, I put out a little plus sign. So I'll type in 48. What's it gonna do here? 1 is a root of 48, 2, 3, 4, 6, 8, 12, 16, 24, 48. Now why do I have that little plus there? Oh, why? So I put the plus inside of the parentheses, so the computer's like, hey, you got a plus sign inside of the parentheses, guess what? Guess you want to print out the symbol plus when I really meant to concatenate. So what are we doing right here? Let's print it out. So for x equals 1 to a number, what are we going through? What is x? X is the perspective roots, right? Is 1 a root? Is 2 a root? Is 3 a root? Is 4 a root? Is 5 a root? Now there's slicker ways we can do this, and maybe we can address those in a couple minutes. But what else do we want to do too? Count the number of roots. What is the variable name that we can have for the number of roots? What do you want to call it? Number of roots. What's that sound? And up at the top here, I'm going to say num roots equals 0. And so every time the remainder is equal to 0, what are we going to do to the number of roots? Num roots equals what? So if it's 5, what are we going to make it? 6. If it's 23, we're going to make it what? 24. So the number of roots is equal to whatever the number of roots used to be plus what? 1. In other programming languages like Python and C++ have little sneaky little things called like plus that you can do. That, this small basic might be too, but num roots is going to take on the value of whatever num roots was plus 1. So if it was 0, it's 1. If it's 22, it's 23. Now, once we get out of the root, once we get done, what do? Counts the number of roots. Can we just display the number of roots? You bet we can. Now, when we're done, how many times do we want to print out the total number of roots? Just once. So it needs to be done outside of the loop. Because how many times, everything within that for loop and that end for, how many times is it going to be calculated or computed or printed? As many times as you type. If I type in 47, 123, 9,000, whatever, it's going to do that. So now I'm going to type in the number. And I'll go back, and if I can make this bigger, I don't know, is there a way to make this bigger? Control plus.
It's like you click in the very top there where you just dragged it.
I'm just. How do I make this text big? I'm just old and I want everyone to see it. So.
Thank you.
But let's just write it here. Let's do 48 again because I know that. Total number of roots is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. What about something like 36? Is 36 going to have an odd or an even number of roots? Odd, why? Because it's a what? It's a square root. So that root is gonna count twice. Because these roots typically have pairs, 1 and 36, 2 and 18, 3 and 12, 4 and 9. Then once you get to 6, it's 6 and 6. I better be right. Yep, I'm right. So we got 9. Okay, we got 9 of these here. Let me paste this into Word if that's okay, make it a little bigger. Is that all right? There we go. Pretty simple program right there. And those you know watching this later, you can go back, type this in. So what do? We asked for it, and we can comment this. Hopefully everyone commented everything that they turned in. Number of roots is equal to 0. Why did I say number of roots equal to 0 right at the beginning? What's the whole goal of that? I have a variable that's equal to 0 before I enter the program. What if I set it equal to 5? It'd be kind of silly, right? Because I've already started counting the number of roots before I enter the loop. And so this is what we call initializing a variable. Some programming languages, they need those variables to be declared at the beginning and to be initialized to be 0. I think Python is one of those. I'm looking for like Andy or someone to nod their head. Does Python need to have the variables declared before they're utilized? Or does it matter? Okay, yeah. So we have those number roots equals 0. I was like putting them up there just because hey, this number roots is popping up and I don't know what it is. Some languages let you do it, and then later when we start talking about Python, we're gonna have a lot of different variables that we can type in. We have numbers, we have strings, we have feature classes, each of which have those different properties attached to those, where here I can concatenate, but in Python and other programming languages, I just can't add 2 strings together and think the computer is going to be smart enough to turn them into strings when one's being treated as a number. And then we got the doubles and the floats and all that other kind of minutia that needs to be handled using Python. Okay, so now we got this here. So now I can, type in something like 25,000. Let me just try 25,000. Oh, look how quickly that went. Let me type in 1,000,000. 1, 1, 2, 3, 1, 2, 3. Boom, 49 roots. How about 5 million? Look at it, it's starting to struggle a little. Starting to struggle, 56. There's 10 million. It's thinking, it's thinking, it's thinking. All right, there we go, finally, come on. All right, 64 roots. Now, to be honest with you, what's the highest that you need to really go up? And there's some debate for this, but do I have to go all the way up to the number? No. Half of it, right? Because once you get to 25, so number divided by 2. And then just for the heck of it, What do I put at the end? I put these little guys right here, right at the end. I still need to count my number. Do it again. Type in 1,000. Oops. Not X, but number. Look what I just did. Did it again. But what did I do? I cut the amount of computational time in half, right? And at the end, I just said, hey, we're gonna go from 501 all the way up to 1,000 and count you as a root because I know number is always going to be a root of what? Itself. It'll always be a root of itself. Now, for the second part, I'm gonna let everyone else kind of figure that out because I want to do two more kind of short little exercises with the while statements. Okay, with the while statements here. All right, so for homework, because this is part of the homework here, we'll look at the homework in a little bit. How do you do a positive number? You do a little if statement. If number is less than 0, say goodbye, I can't do this. And then what? You just throw the rest of this stuff into your if loop. Then we're gonna go through all this minutia here. Otherwise, we're gonna get out of it. That's it. That's pretty easy, right? All right, let's look at another one here. Because I want to look at something called nested loops, which I really like, which I think are pretty neat, pretty funny. Because we can start to look at Pythagorean triples, just like you did for your homework. So we got the basis for one of the homeworks here. Now we're going to do a guessing game. Yeah. Well, this is part of homework too. We're just going to do the basics for a guessing game. Okay, so what are we going to do? The first thing we're going to do is the computer picks a number between 1 and 100. Okay. Computer picks number. And then the user guesses. Now, what are the three possibilities that can happen? Three possibilities. If the user guesses, what are the three possibilities? It could be the same, it could be too high, it could be low. Because do we want to say it's too high or too low? Yeah, because if you're just like, you're wrong, guess what? So high, low, big, yes, we got it. Yes, we guessed it. Now, if it's yes, what do you want to do? I'm done. If high, what do you want to do? Or low, turn right back around and it's the user guesses. So how many times are you going to go through the loop till you get it right? How do we signify that? If or while user gets it right. While user gets it right. Guesses it right. Now, what I'm going to do here is I'm going to set a variable called flag. Flag equals 1. And when we enter, we're going to say flag equals 0. Flag equals 0. So the only time the flag is equal to 1 is when you get over here and you're out of the loop. So our while statement is going to be while flag equals 0. Once it gets to 1, we're done. We're out of the loop. And then you're going to have to do some additional things like, hey, count the number of guesses. So we'll put the shell of this program right here, and then I'll let you all kind of make it look a little bit prettier. Okay, so what's the first thing? Computer picks a number. What's the number that you want to call it? We'll just say number equals what? All right, let's go to this math library that I provided last week. And I'm going to do Control F, and I'm typing the word random. Okay, so random. Math.get random number max number. Okay. What's the max number I said? And we'll just go up to 100. And just for the heck of it, what do I want to do? Text window dot right line. Why do I want to do that? What if it has decimals in it or any of that other stuff? Ugh. Let me just put it 74. 88. Okay. So number equals math dot get random number 100. So it's going to give us an integer between 1 and 100. Next, I just wrote it out, and now I'm just going to go and comment this thing out so it doesn't run. And then I'm going to set a variable called flag equals 0. And I'm going to go through and run, like I said before, I'm going to go through, and the only time that flag equals 1, and flag, you know what I mean by flag, you put like the little flag up, like, hey, I put a flag up, meaning like something changed. So I just want to make sure we kind of separate. I put a little flag up, meaning, hey, we put a flag up. Okay, flag equals 1. Because how many times is it going to go through? So until it gets to the flag, and the only time it hits the flag is when the number equals what? Guess, whatever guess is. What's guess going to be? Whatever you type in. Okay. Now we've already have some code here, right? Don't we have some code here where it says, please type in a number? Let's do this. And then we're going to set something that says while flag equals 0 and wow. So I want to put this in a loop here, and then we're going to just do everything in here. While flag equals 0. Because what is the minimum number of times that you can guess? Once. If you just happen to guess that number between 1 and 100, you still got to go through the loop, right? And we can cater this to, I'll let you all kind of finish that all for homework, where that you got to enter the loop at least once, right? So what am I going to do? I'm going to ask for a number. What do you think we should call it? Guess. This is the variable, we'll call it guess. We'll just say, please type in a number between 1 and 100. Now we can change it to 1,000 or whatever later. It's just going to take a long time to play. Now, what do we have here? We've got 3 different possibilities. What are the 3 possibilities that we'll set before? If the number equals the guess, what happens? You're done. You got the right number, we're done. So if possibility 1, number equals guess, then what? And we'll leave the counts and all that other stuff for you to count the number of guesses. We'll let you all do that for homework. What do we win? Nice job. You guessed Or what do we need to do? I gotta write stuff. I'm starting to get in a. Nice job. You. Now here would be a good place to put number of guesses equals number of guesses plus 1. Or put it down at the bottom here, because every time you go through, it's going to be whether you get it, whether it's too low, it's too high, it's always going to be a guess, but I'll let you all figure that out. Okay, else if. What's the other possibility? It's too high, where that guess or number is less than guess, then what? If the number is less than the guess, then what? Guess is too
Or too low or whatever.
high. Guess again. What's the only other possibility we have left? Else, do we need to do an else if? No. One thing I want to do is make sure this if statement, all these are lined up, and then these are tabbed, and then the while statement. So everything occurs within this loop. Everything occurs within this loop. Now, what else happens if the number equals the guess? We set that flag to 1. If we don't change that flag to 1, what's going to happen? You're going to be in this loop forever. Who wants to be in the loop forever? Not me. Flag takes on the value of 1. We can set it to whatever we want. And this is very kind of bare bones, because what you're going to do later is you're going to count the number of guesses while we go through and then print out the number of guesses when we're done. What's the maximum number of guesses that you should take to select a number between 1 and 100? What? What's the maximum number of guesses you should have? Should. Someone was like, let me guess 1, let me guess 2, let me guess 3. Well, what if I pick 50? What's it going to say? You're too high or too low? What's the possibility? If it's too high, then guess what? I have to go between 0 and 49. And what do you think I'd pick after that? 25. All right, too low. We go between 25 and 50. So we're looking at about 6, like 2 to the 6th power, between 2 to the 6 and 2 to the 7. So we're looking at about 6 to 7 guesses max. All right? 6 or 7. All right. Well, let's make sure. Let's see if this thing works. All right. Type in a number. I'm going to say 50. Guess is too high. So I'm going to guess 25. Guess is too high. 12. Guess is too high. Oh yes. Oh no. Oh no. We'll point something out. Oops. Low. That's gonna be really fast. Okay. So if the number is less than the guess, all right, let's do it again. All right, 50. Guess is too high, go 25. Guess is too low, what should I pick next? 37. Guess is too low, 44. So between 38, let's try 40. Too low, 41, 42. Nice job. All right. So this is what I want you to do for the homework. Now, I also want you to pick out and if you want to do, you can kind of set up the, input. So instead of 100, like, you have been at 1,000. What's how many numbers now? That's like 10 guesses, right? 10 to the 12th is what, 1,024, something like that. But we're just going to do 1 in 100. Because every time you go through this loop, because you got to do at least once, right? You got to be at least once. And all it did was it got to 44 right here. I see you, Greg. Once it got here, it said flag equals 1. Let me go through. Oh, can't do it again because it said while that condition is true. All right, Greg, you have a question?
Yes, sir. I don't. Obviously, you probably can't help me, but so mine is going. So I got to the end of mine, and I typed in 84. My guess is too high. Guess again. Typed in 83. Well, that guess is too low. Guess again. Which I went back to 84, but that's too high. Guess again. Is that so? I'm not sure what I'm doing wrong.
All right, that's a tough one. What I would do is I'd print out the number to make sure it's not a decimal. Maybe it's asking for a decimal.
Okay, yeah, because that must be it. Okay, all right, thanks.
All right, and then how do we change things to decimals or change things away from decimals? Your computer might have had decimals, but guess what? I'm right here. I'm going to type in the word round. Look what I have. This rounds a number to a given integer. So if we really want to, we could round that random number. Now, I'm not really sure what's going on with gray. All right, so I'm going to cut and paste this in here into Word. And then if you're watching this later, you can basically pause it and then see what we did here. So I'll put this all in one page here. I'll give everyone a chance to kind of. There we go. So take a minute or two, just look at this, make sure. So we got the basis for that. Now you're gonna have to go through and print out the number of guesses and all that other good stuff, because if we kind of pop ahead to the homework, if I look at exercise 3, what you're gonna do is write a short program. And I think we should be able to do most of these here. Write a short program that asks for a number between 1 and 100. You can change the range. And tells you the number of guesses. And like I said before, I used a flag or over or something like that. Over equals 0, over equals 1. In digital logic, 0 means false, 1 means true. Over, I meant, over meaning is the game over with. Okay. But I just set this thing called flag. Last one here, we got Pythagorean triples. Okay. Now, you remember these Pythagorean triples from last week? Did anyone calculate the Pythagorean theorem? Exactly. Did you get really wacky numbers?
Yes.
Yes. Yeah. Now, Pythagorean triples, these are some Pythagorean triples like 3, 4, 5. 3 squared plus 4 squared equals 5 squared. 6 squared plus 8 squared equals 10 squared. 5 squared plus 12 squared equals 13 squared. What I want to do is I want to go through and calculate those. Now, what I think I'm going to do we can look at some different types of algorithm designs for those is, what are the variables in Pythagorean triples? What are the variables? A, B, and C. This is what we call just brute force. A, B, C. What I want to do is just, let me check 1, 1, and 1. 1, 1, and 2. 1, 1, and 3. 1, 1, and 4. Who wants to do that? Who wants the computer to do that? And so this is what we're going to call a nested loop. Nested loop. Meaning, hey, we are going to go through, and I might even have the program ready because I always get a little confused with the nested loops. Meaning we do loops within loops. Okay, and if I can open up we can kind of get a method to the madness, and then kind of reverse engineer it a bit. Now let's open up. Oh, here's my Pythagorean triples. Watch what I have here. All right, cool. This is a program. Watch what this program does. We'll run it and then we'll go back and figure out what it does. These are all the Pythagorean triples whose hypotenuse is less than 500. Look at that. That's pretty cool. This is what we call brute force, meaning like we're going to go through and do every single calculation. Do we have to do that? No. You all know about the 93, 476, 485 Pythagorean triple? You didn't know about that?
No, there's this many.
Oh, yeah. There's a whole lot of them because once you get to 3, 4, 5, any multiple of 3, 4, 5 will be a Pythagorean triple. 6, 8, 12, 9, 12, 13, or 9, whatever. 9, 12, 15, whatever. So, and then you got these new ones like 93, 93 isn't a prime number, but 31, 480, and 481. 31's a prime number. So let's look at this here. We're just going to go up to 500. And I'm going to show you what this loop does here. Okay, I got my little loop here. And we've got A, B, and C. Hypotenuse equals math dot power C comma 2. Legs equals math dot power C comma 2. All right, we'll worry about that stuff in a bit. So we got A, B, and C. Okay, A, B, and C. So for C equals 2 to 500, for A equals 1 to C, for B equals 1 to A. What is C equal to? C is always going to be the longest leg, right? So it's going to be on the outside. So first, we're going to start at 2, right? So A is equal to 1 to C. So the first time I go through the loop, we're going to go to 1. And then what's B going to be? 1 to A, which is, so we're going to do 1, 1, 2. 1, 1, 2. Is that even a real triangle to begin with? It's not, because you can't have real triangles that are that length. Right? Need to be greater than this. And so hypotenuse is equal to math dot power C comma 2. What's the hypotenuse equal to? 4. What are the legs equal to? Let's add them up. Basically a squared plus b squared. So is 1 squared plus 1 squared equal 2 squared? No. So it's not going to write it. What are we going to go to next? Next time we go through this loop, 1 to A, we're going to go 1, 2, 2. All right? Is 1 squared plus 2 squared equal 2 squared? No. Next, we're going to go to 2, 2, 2. Is 2 squared plus 2 squared equal to 2 squared? No. No. All right, finally, once we get here, what's going to be C next? 3. And then we'll just start again. 1, 1, 3 is 1 squared plus 1 squared. Now, I could start these at 2 or whatever, or the square root of 3 or whatever, because I'm doing what we call brute force, all possible combinations. Because I could have started these at smaller numbers, because the minimum this can be, the very minimum this can be is the square root of 3. Square root of 3 plus the square root of 3, square root of 3 squared plus the square root of 3 squared equals this, or actually, this divided by 2. 1.5, 1.5, but that gets, you don't want to start dealing with that. Okay, what do we do next? 1, 2, 3. Does that work? No. 1, 3, 3. 2, 3, 3, 3. Eventually, we get to one that's 3, 4, 5. Know what I mean? Who wants to do all those calculations? This is basically what a nested loop does. Looks for all the, use the word permutations of these, all the permutations. Now, why does it take so long to run all 500? How many Pythagorean triples might you have? A couple hundred. How many different combinations of these things do we have? So we look at permanent permutations, or sometimes we use the word discrete methods, or we use the word combinatrix. Combinatrix. Now, someone smarter than me can figure out, hey, we don't need to do the 1, 1, 2. Let's just start at 1, 1, 2, 1.5, 1.5, iterate up. So we get rid of a lot of needless, calculations. But this is what we call brute force, going through and doing this. And once you start doing like matrix analysis and things like this, this is really where you want to get into algorithm design. Because imagine if I did, instead of 1 to 500, 1 to 1,000 Pythagorean triples, we'd be here an hour. You saw how long it took to find, hey, 31, 478, 482. We got one there because it's doing 31, 477, 82, 41, 476, 482. So all those different combinations of those. But I've got this one here, and then while it was there, it says, hey, let's count up the number of triples, and at the end, but I bet you, just for the heck of it, let's do num calc equals num calc. What do you think I'm trying to do here? Plus 1. How many different calculations we are running? Now, instead of 2 to 500, let's just do to 2 to 20. Okay, so hypotenuse 2 to 20. Oops. That we did num calc. I got to get this out of that if statement. All right. Here. So just from 120, we got 1,539 different calculations of just this stuff here. I see Chima thinking in the background, like I could do this a lot better, right? So I'm the teacher. No, there are slicker ways to do this. I'm not an algorithm, I'm not an algorithm design person, and I do, but now it's at 20, let's go up to 100. Do you think it's just going to be 5 times 1,539? No. Even though, 20 times 5 equals 100, we got a whole nother set of calculations. So 171,699 calculations. And then we go up to 500. We get really ugly really quickly. This was 50. You know, so we're doing tons and tons of these calculations. Now, when we start getting into Python, we have these things called pandas, which are Python numbered dictionaries. You know, and I played with those a little bit, which probably some Pythagorean triples in there, and some neat little Python dictionaries in there that help us do this a little better. But now we're looking at 20,958,499 of these permutations, where it only picks out 386 of those Pythagorean triples. All right, so how about we look at the homework and then I'll get, I hate when people say I'm giving your time back. It really annoys me, but we'll be done and we'll have some. You guys hear that these days with the virtual, like I'm going to give you back half an hour, and I just, it's so off-putting to me because you're taking my time to begin with. Like you're not doing me a favor giving me my time back that, so. And I know David sits in a lot of meetings, yes. Yep, lucky, thank you so much. I should be, okay, so. For homework, we're gonna have a multiplication table. You type in the multiple, so imagine you're writing it for my kids. Okay, imagine you write it for my kids, the 2, the 3, the 4, the 5, whatever. Okay, so my kids are doing the 12 times 12s or whatever, okay? Make sure the output looks good. Okay, catering this output from the 9-year-old to the 99-year-old should be able to understand this. Next one. Determine if a prime or composite number. We kind of looked at this already. We used remainders because guess what? Next week or the week after, you're going to be doing the same thing in Python. But, the loops and the syntax are going to be totally different. And in some languages, we have the little percent sign, which is remainder. So we can use that little percent sign instead of the math.remainder because we start typing in like text window.write. Python's going to say, what you talking about? Well, I don't know what this stuff is. Okay, and I think we just use print statements. It'll print to our output there, but we can also write it to HTML, CSV files, or whatever else that we want to. Some things we've done in the past. Next one, interest rates. Okay, the thing about interest rates, I always like talking to my kids there. If you have like a 10%, my stocks now are doing okay, but they make 15% a year. So if it's like 15% a year and I put in $10,000, I make $1,500. So now I have $11,150. Am I going to make $1,500 the next year? No, I'm going to make 15% of that $11,150 the next year. And so that's what we call compounded interest. So what you want to do here is calculate your interest and then compound it every year. There's formulas that you can use to do that. You can Google those, or you can just say, hey, whatever it was the year before, multiply times 1.05. Because, right, isn't the number plus the number times 1.05, 1.05 times the number? I think a lot of people, let's look at that real quick. Really, think about what we're doing. I'm going to point this to the people joining us. I want to make sure you can see this here. When we do compound interest, okay, and you can do some of the things with the powers, but I was talking about maybe doing this in a loop where that I have $1,000 times, let's just say 15%, that equals 150. So the next year we're going to do 1,150 times 15%, which equals this number. So, but this number here, this is going to be, whatever. Value times 0.15. Right? What's value times 1.15 value equal to? 1.15. If I made this thing x, we would all know what it is, right? X plus 1.15x equals what? 1.15x. We start putting numbers on these, and I think a lot of people go into, I don't know what to do here. Okay, just think of it, these are variables. So I'm just thinking of ways that we can go through and do these in loops without you all having to deal with exponents, we gotta deal with this stuff, all that other good stuff. This is just compounded yearly. You know, they got the monthly interest and all that other stuff here. All right, Pythagorean triple, someone might have already written this program for you all, so take a look at this with nested loops, and then we all started working on the guessing game. So what you need to go through and do is run the program, count the number of guesses with your hand, and make sure it matches up with, you know, what the numbers that's being written out. Okay, have your little brother or whatever, have them play and make sure they know how to do it. Because what I'm going to want is, don't put in a negative number, because me, I'm like a jerk, and you know, when I'm grading it and I'm in a bad mood, I type in a negative number, and guess what? Yeah, I read the number. I get stuck there. I keep, you know, too high, too low. I just keep typing in negatives. Okay. So think of ways not only to, you know, you might have maybe another flag, like you're done. You pick the flag, you typed in a number, you're out of here. You're out of here. Okay, maybe do that. So you can get real creative for flags, while loops, compound while loops, while flag equals 0, and make sure the idiot types in a positive number. Now, how do we express that programmatically? That's a little bit more of a challenge. You know, how do we talk through like the number plus the number and all that other good stuff? You know, I just set up a little flag. It might be negative, negative number typed in, or neg, or whatever we want to type in, and say, all right, both of these need to be true. While flag equals 0 and typed in negative equals 0. And so if you type in a positive number within a negative number within that loop, we set that flag, you're done, you're kicked out of the loop, and we're done. So that and statement might be applicable. Okay. So even these simple programs can get increasingly, you know, complex. But I want to kind of, you write this for the 9-year-old to the 99-year-old. Okay. And so they can get increasingly complex, but I want us to be able to utilize some of the conditional statements, the for loops that we have right here, as well as the if and the compound statements, the ands and the ors attached to these. Because next week we're going to be doing the same thing in ArcGIS Pro with Python. Now we're not going to be pointing, clicking, and all that other stuff there. We're going to just write a little box here where you make a little drop-down number and you add in 2 numbers, and it just prints out what the numbers within the confines of ArcGIS Pro. And then the week after that, we're going to have it start interacting with, hey, we got a feature class here. And so if you said you typing in a number, our input isn't going to be a number or a word. It's going to be a feature class. Hey, count the number of features within the feature class. And we can do that. Now, there's a lot of functionality to do this. We're not going to do this by scratch. I don't even do it by scratch. And so I put in my own little code next week that will do that. All right, so any questions for me here? Any questions for me here? So we got some good, you know, we got some good assignments to work on here. I'm going to be unavailable the next 2 days. We are taking a student over to the NCDOT Transportation and Research, some symposium over in Raleigh. That's all I know. I should have gotten a hotel, but because I got to be there first thing tomorrow, so I get to drive all the way back. So, but so I'll be largely unavailable, but sometime tomorrow I'll try to get a recording of this up there and get you all ready to go. So I'll see everyone later. And then next week, make sure we got ArcGIS Pro installed, because we'll be working directly with ArcGIS Pro and then some of the Python functionality in there, the Python windows that we looked at a little bit. So we'll see you all later. Thanks for coming, Janice. It's good to have you here. And I'll stop.
Thank you, Mr. Maroney.
All right. See you later, Quan.